System Pluto was the first Kuiper Belt object found, and we didn't discover any more for something like 60 years. On November 2, 2015, the globe received its first glimpse at an item from the Kuiper Belt. It was one of the most remarkable photos from space ever made public. But that's just changed. The James Webb Telescope has just obtained the sharpest image of the Kuiper Belt in history, and it's nothing like anyone imagined it to be. The Kuiper Belt is located in the outer solar system and creates a frigid, donut-shaped area. It sits beyond the orbit of Neptune, the eighth planet from the Sun. At first, its shape was the most interesting thing about it, but then it was evident that this was going to be one of the most interesting things about our planet. The Kuiper Belt is named after astronomer Gerard Kuiper, whose work in the mid-20th century established the framework for understanding the region beyond Pluto, but he wasn't the one who discovered it. In 1951, Kuiper presented a scientific study that arose about the presence of things beyond Pluto. Kuiper's research primarily focused on the likelihood of things being beyond Pluto, but it didn't make comprehensive predictions regarding the specific features or organization of the objects within this region. Pluto was formerly regarded as the defining component for the Kuiper Belt, but it's now acknowledged that Neptune's orbit, rather than Pluto's, creates the inner boundary of the belt. The gravitational force of Neptune has played a major role in defining the dynamics of the Kuiper Belt. Although Kuiper's predictions were not directly aligned with the discoveries eventually made in the Kuiper Belt, his pioneering thoughts and achievements were highly known among astronomers over time. The overall concept of the Kuiper Belt and its association with objects beyond Pluto became tied to Gerard Kuiper. In 1930, astronomer Clyde Tombaugh spotted Pluto in what we now know as the Kuiper Belt, making it the first one. During its discovery, the understanding of the outer solar system was limited, and astronomers did not predict the presence of a substantial population of frozen worlds beyond Neptune. The prevalent conception of the solar system includes the inner rocky planets, the gas giants, and the outermost frozen giant Neptune. Pluto's identification, despite its eccentric and inclined orbit, led scientists of the time to treat it as a lone planet. It wasn't until 62 years later, in 1992, when the second Kuiper Belt object was discovered. At this moment, it was evident that Pluto was not a solitary entity but part of a greater population of objects in the outer solar system. The subsequent discovery of numerous KBOs verified the existence of the Kuiper Belt, a region housing a diverse array of cold worlds beyond Neptune. Pluto's unique significance in astronomical history resides in its initial classification as the ninth planet, a title it held for several decades. However, as our understanding of the Kuiper Belt grew and with the finding of new KBOs, particularly those with bigger diameters than Pluto, the International Astronomical Union updated the criterion for planetary status in 2006. Pluto was then classified as a dwarf planet, but it'll always remain one of the most important discoveries in our solar system, since without it, we would have never actually explored into the area of the Kuiper Belt. This unique location is considered an extension of our solar system because it is part of the same cosmic neighborhood and is impacted by the gravitational forces of the Sun. While the 8 major planets, including Neptune, dominate the inner solar system, the Kuiper Belt stretches the borders of the solar system into the outer regions. It is unique from the inner solar system and is characterized by a collection of ice objects, including dwarf planets, asteroids, and comets. According to NASA, the material in the Kuiper Belt is believed to be leftovers from the early solar system, dating back about 4.6 billion years, and is expected to have preserved conditions and materials from that time. Inside this belt, we've got Pluto and its moons, as well as additional dwarf planets like Haumea, Makemake, and Eris. Not just that, but the Kuiper Belt is also home to a diverse variety of tiny icy bodies. It's a particular aspect of the solar system that we don't actually have all over. The Kuiper Belt is substantially larger than the main asteroid belt, which is a collection of stony objects, predominantly asteroids lying between the orbits of Mars and Jupiter. It is relatively thin and contains a significant number of small to medium-sized bodies. On the other side, the Kuiper Belt is a more large and remote location. The bulk of the Kuiper Belt is predicted to be 20 to 100 times bigger than the mass of the asteroid belt, indicating that the Kuiper Belt includes a more substantial amount of material, both in terms of the number of objects and their overall mass. That's part of the reason why it was so startling that this discovery took so long initially. But just because it took a while for the discovery here doesn't mean that this place isn't essential to the solar system. It's home to a wide collection of celestial entities, including dwarf planets like Pluto, Haumea, Makemake, and Eris. Pluto, discovered by Clyde Tombaugh in 1930, was originally considered the ninth planet until the International Astronomical Union updated planetary criteria in 2006, resulting in its reclassification as a dwarf planet. Pluto, with a diameter of approximately 2,377 kilometers, orbits with other prominent dwarf planets in the Kuiper Belt. Study into Pluto has also helped scientists and researchers grasp this faraway region a lot better. This was just the start, though. Haumea, discovered in 2004 by a team led by Mike Brown, adds to the Kuiper Belt's diversity with its distinctive elongated shape, probably a result of rapid rotation. This dwarf planet, approximately 1,960 kilometers in diameter, has offered us a lot of knowledge on the interesting properties of Kuiper Belt objects. Makemake, another finding by Mike Brown's team in 2005, shows its own peculiar traits. With a diameter of roughly 1,430 kilometers, Makemake lacks a large atmosphere. Nevertheless, its luminous surface comprised of methane, ethane, and tholins characterizes it as one of the brightest objects in the Kuiper Belt. Eris, also discovered in 2005, is somewhat smaller than Pluto but more massive with a diameter of approximately 2,326 kilometers. Eris is a key member of the Kuiper Belt, and its discovery contributed to the reevaluation of the concept of a planet and expanded our understanding of the variety and dynamics of objects inside the Kuiper Belt. Together, these dwarf planets give vital insights into the composition and evolution of the Kuiper Belt and its role in the broader context of the solar system history. If it weren't for them, we would be utterly in the dark about the area. A lot of people throughout the world have confused the Kuiper Belt with the Oort cloud, but what they don't realize is that the Kuiper Belt is more densely populated with objects and is expected to be a source of short-period comets that have significantly shorter orbital periods. On the other side, the Oort cloud is an even more distant and spherical area that envelopes the entire solar system. It is believed to span from roughly 2,000 to possibly 20,000 astronomical units from the Sun. The Oort cloud is made of frozen bodies frequently compared to filthy snowballs, and is the suspected source of long-period comets with highly elliptical orbits that bring them closer to the Sun. While the Kuiper Belt and the Oort cloud are diverse locations and shapes, they have the common attribute of being repositories of frozen bodies. Both are considered potential sources of comets, astronomical objects comprised of ice, dust, and volatile chemicals, which become visible as they approach the Sun, and the solar wind drives them to develop a brilliant coma and a tail. So, the confusion can make sense sometimes, but it's crucial to grasp the differences. One of the things about this place that has scientists startled is that the amount of material in the Kuiper Belt today might be just a small fraction of what was previously there. What we have today are quite literally simply remains, and the genuine stuff has long evaporated. But this wasn't random. The NICE model is a theoretical framework that implies a sequence of substantial orbital adjustments in the outer solar system, particularly involving the four largest planets: Jupiter, Saturn, Uranus, and Neptune. According to it, the large planets in the outer solar system did not always inhabit the same orbits they do today. Instead, they underwent a period of rapid orbital change. The hypothesis argues that interactions between these large planets led to dramatic alterations in their orbits. As a consequence of the altering orbits of the large planets, the NICE model predicts that a considerable quantity of material in the Kuiper Belt, initially believed to be 7 to 10 times the mass of Earth, could have been lost. The gravitational interactions and changes in the orbits of the large planets could have caused material in the Kuiper Belt to be scattered, expelled from the solar system, or moved to different locations. Because of what's going on, the Kuiper Belt is presently in a state of steady degradation. Collisions between items within the belt can cause fragmentation, leading to the formation of smaller Kuiper Belt objects. Some of these smaller objects may become comets. Others won't. But what doesn't become a comet is smashed. The dust created by collisions can be blasted out of the solar system by the solar wind. The overall mass of all the material in the Kuiper Belt is estimated to be no more than around 10% of the mass of Earth. That can make it look small, but it's not. A considerable number of Kuiper Belt objects have been discovered to have moons. These moons are smaller entities that orbit around a larger parent object. This phenomenon is not restricted to planets but extends to other objects in the Kuiper Belt. Along with the moons, several KBOs exist as binary systems. In a binary system, two objects of nearly comparable size or mass orbit around a common center of mass, sometimes referred to as their barycenter. These binary pairings can have a range of orbital properties. Among these, certain objects actually touch, giving a characteristic peanut shape. This design is known as a contact binary, where the two components are in physical touch with each other. The combined gravitational forces formed them into this particular form. But this wasn't always public knowledge. NASA had to put in a lot of work into it. Pioneer 10 was one of the first ones to go near it. Pioneer 10, launched by NASA on March 2, 1972, was a revolutionary spacecraft built for the exploration of Jupiter and its surrounding atmosphere. Equipped with scientific instruments to explore Jupiter's atmosphere, magnetic field, and radiation belts, it made history as the first spacecraft to transit the asteroid belt, and in 1983 set another historic milestone by being the first spacecraft to traverse the Kuiper Belt region. Although Pioneer 10 entered this region, it did not expressly explore any cold worlds as none had been identified aside from Pluto at the time of its launch. The spacecraft's primary mission centered on Jupiter, and it returned crucial data on the gas giant back to Earth. Pioneer 10's trajectory and endurance allowed it to journey far beyond the orbits of the known planets, contributing to our understanding of the farthest limits of the solar system, barely pairing the Kuiper Belt. This paved the way for further expeditions to study this distant and intriguing region. Later missions like Voyager 2 and Cassini considerably expanded our understanding of the outer solar system. Voyager 2's landmark visit to Neptune's moon Triton in 1989 and Cassini's research of Saturn's moon Phoebe in 2000 provided significant information on these celestial bodies. Some of these moons are considered to have originated from the Kuiper Belt, having been captured by the gravitational force of their respective planets. The New Horizons spacecraft made history by making the first-ever flyby of Pluto in 2015. During its voyage, New Horizons acquired images of a Kuiper Belt object known as 1994 JR1, an asteroid about 90 meters broad, spotted from a distance of 170 million miles, providing significant data regarding the composition and features of Kuiper Belt objects. In 2014, the Hubble Space Telescope made important contributions by identifying 3 KBOs that were considered potential targets for NASA's New Horizons Pluto mission. The telescope also spotted 2 frozen mini-worlds within the Kuiper Belt, situated near the solar system's boundary. During the same year, these findings based on photos collected on June 24 encouraged NASA to allow a more extended search for Kuiper Belt objects. The primary purpose of this enhanced search was to discover a suitable object for NASA's New Horizons probe to investigate up close following its flyby of Pluto. The 2 objects discovered during the search, currently named 11101113Y and 0729F, are located around 4 billion kilometers from Earth. Hubble's role in Kuiper Belt study stretches back to 2003 when it obtained 2 photos taken 12 hours apart of a Kuiper Belt object designated 2000 F53. This particular object, initially detected from Hawaii in March 2000, played a significant role in directing Hubble's observations. The 3 newly discovered Kuiper Belt members revealed by Hubble are unusually faint, up to 100 times dimmer than the previously described 2000 F53. Their faintness renders them invisible to the human eye, necessitating the use of computer analysis by astronomers to locate them. The advanced camera for surveys on Hubble followed one of these objects on January 26, 2003, making it evident that we were dealing with something gigantic. However, it wasn't until the James Webb Space Telescope entered the mix that things truly became fascinating. Its enhanced capabilities opened up unparalleled chances for observation and analysis. The James Webb Space Telescope is a state-of-the-art space observatory specializing in researching the cosmos, including places like the Kuiper Belt. Because it uses infrared technology, all items with a temperature above absolute zero emit infrared light. The strength and spread of this radiation depend on the object's temperature. In the Kuiper Belt, where temperatures are exceptionally cold, The emitted infrared radiation comes in the form of longer wavelengths. This makes it easier for this telescope to gather information about it.